Hey everybody, here is the video for home connections 67 and 68. Number 1, Frankie's dad made scrambled eggs for the family's breakfast. He started with a full carton of 12 eggs. He used 8 of the eggs. What fraction of the carton did he use? So he used 8 out of 12. And that's one fraction that you could write. And then it says to write a bunch, or at least 2 equivalent fractions. So you could cut the top in half and the bottom in half and write 4/6. You could cut the top in half and the bottom half in half again and write 2/3. So those would all be equivalent fractions. You also could have doubled the top and doubled the bottom. That would also be an equivalent fraction. So there are an infinite number of possibilities, but those are probably some of the most common. All right, number 2, Frankie found a quarter on the sidewalk. What fraction of a dollar did Frankie find? Write at least 2 equivalent fractions. He found 1 out of the 4 quarters it takes to make a dollar, and I know that 1/4, if I multiply the top by 25 and the bottom by 25, is the same thing as 25 out of 100. Again, there are an infinite number of possibilities. In terms of money, those are probably the 2 best equivalent fractions to write. But again, you could double the top and double the bottom. And though it doesn't quite make a lot of sense with money necessarily, 2/8 would mathematically be okay. But probably the ones in red are the best. All right, once you change 1/4 to 25 hundredths. Once it has a 100 in the denominator, writing it as a decimal is very easy. And of course, that's how you write money, is you write it as a decimal. Number 3, Frankie ate 3/8 of a granola bar. Her friend Pablo ate 4/8 of the granola bar. What fraction did they eat in all? So we're doing 3/8 plus 4/8 equals 7/8. That's how much they ate. And I know that 8/8 would be the whole thing. So how much left? 1/8 is left. They ate 7/8. 1/8 is left. Remember, if all else fails, draw a picture. I'm going to draw a rectangular granola bar because I would imagine most granola bars are rectangular. Cut it into 8 pieces. So imagine that Frankie ate 3/8 and Pablo ate 4/8. And you could see that that's 7/8 all together, and there's 1/8 left. So remember, pictures can always be helpful. Number 4, write each fraction as an equivalent fraction with 100 in the denominator. They all have a 10 in the denominator, so if we multiply the bottom by 10, we need to multiply the top by 10. Sometimes kids just think add a 0 to the top and a 0 to the bottom. That's okay too, but what we're really doing is multiplying the bottom by 10, which means we also need to multiply the top by 10. So that way we're multiplying by 1 whole, and that gives us an equivalent fraction. So 2/10 is the same as 20 hundredths. 6/10 is the same as 60 hundredths. 9/10 is 90 hundredths. And 5/10 is 50 hundredths. We could think strips and units. 2/10 would be 2 strips, and that's the same as 20 units. 6 strips is 60 units. 9 strips is 90 units. And 5 strips, 50 units. Number 5, add or subtract. When the denominators are the same, it makes life very easy. 1 2/4 plus 3 2/4. I'm going to add my whole numbers together. A big ol' 1 plus a big ol' 3 is a big ol' 4. 2/4 plus 2/4 is 4/4. But I think a much better way of writing that would be 4 plus another whole. Big ol' 5 is what I'm going to write. Letter B, 1/5 plus 2/5 equals 3/5. 4/10 plus 23 hundredths. Remember, if the denominators are not the same, make them the same. So I'm going to change 4/10 to the equivalent fraction of 40 hundredths. Ah, now it's easy. 40 plus 23, 63. 40 hundredths plus 23 hundredths is 63 hundredths. 50 hundredths minus 2 tenths. Again, if the denominators are not the same, make them the same. 50 hundredths minus 20 hundredths equals 30 hundredths. 10 twelfths minus 6 twelfths equals 4 twelfths. 75 hundredths minus 5 tenths. Again, if the denominators are not the same, make them the same. 75 hundredths minus 50 hundredths is 25 hundredths. Okay, on to page 68. Frankie wrote this equation on her paper during math class. 1 2/3 is the same thing as 3/3 plus 2/3. Is Frankie's equation true? Yes, way to go, Frankie. Because this is the same as a big old 1, and there's that 2/3. So a big old 1 2/3 is the same thing as 3/3 plus 2/3. It says to write 3 more equations for 1 2/3 that are all true and all different. Our denominator needs to be 3 the whole time. So 1 2/3, I know that that big old 1 is the same as 1/3 plus 1/3 plus 1/3, because that is 3/3. And if I add another, let's see, 1/3 and 1/3, that equals 1 2/3. You can have anything, but this is just an example. So really quick, this is my big old 1 plus 2 more thirds is the same as 1 2/3. Okay, I'm going to do another one. Let's see. I'm going to do a big old 1 plus 1/3 plus 1/3. That's the same as 1 2/3. And the last one, I'm going to do it a little bit differently. I think I'm going to do, how about this? A big old 2 minus 1/3 is the same thing as 1 2/3. And that one might be hard for a couple of kids to visualize. So let me draw a quick picture just to show you what I was thinking. So I'm going to shade in 2. So here's 1, and here's 2. A big old 2 minus 1/3. I'm going to literally erase a section like that. And you can see that when I erase a section, it is 1 2/3 like it's supposed to be. So any addition equation or subtraction equation, as long as it equals what it's supposed to equal, 1 2/3, then there are quite a few possibilities. Here are just a couple. Number 7, Frankie's teacher asked each of the students to cut a square of grid paper any size they wanted. Frankie cut a 10 by 10 grid, that's this one, and Lori cut an 8 by 8 grid. Then the teacher said, each grid you cut, no matter the size, has a value of 1 whole, right? If you have 1 whole cookie, and then another person has one of those gigantic cookie cakes, right? And it's like a huge cookie, they have a whole cookie as well. They're different because they're different sizes. So they can each be a value of 1. It just sort of depends on what you start with. And she is asking us to shade in exactly 1/4. So 1/4 of Frankie's grid would be 25 squares. And 1/4 of Lori's grid would be 16 squares. All right, letter C. Why did you need to shade in a different number of squares on each grid, even though you shaded in 1/4 on both of them? So the reason that one answer was 25 and one answer was 16 is because the grids are different sizes. Okay, and you could, if you wanted to, Frankie's grid had 100 squares, so I could say that 1/4 of 100 was 25, right? If I cut 100 in half, and then in half again. 1/4 of 100 is 25, and 1/4 of, let's see, Lori's was 8 by 8, so that's 64. And if I cut 64 in half and then in half again, that's 1/4 of 64, which is 16. So because they were different sizes, 1/4 of them is different because they started off as a different size, right? 1/4 of our classroom would be about 6 kids. 1/4 of, a stadium at a packed Indians game would be a whole different number. All right, let's take a look at the answers to home connection 67 and 68. All right, kids, I will see you in class.